Assalamualaikum. My name is Zareen Zurika binti Norizan. So I am the third year of Technical University of Malaysia. So this is my project for my BDP1. My title is Development of a Smart Street Lighting System with the Fault Detection using IoT. Firstly, I want to thank both of my panels, which is Dr. Muhammad Badri bin Nursha and also the Encik Azhar bin Ahmad. Also, I will give my thanks to my supervisor, which is Madam Hariani, for giving me the guidance to do this project from the first week. Okay, this is the table of contents for my presentation. The first one is the introduction. What is street light? Okay, basically, everyone knows what is street light, which is a pole that is located at regular interval along a public roadway, road or streets, or also in highway. Okay, in this project, the fault detection can be used an important technology that can detect if there is any broken street light or malfunction street light anytime. Okay, this type of technology can detect which street light that have fault and did not turn on accordingly it will be a greatest help to the local authorities and the technician to do the maintenance works because they will know exactly where the faulty street light located. Okay, this project used the GSM module to send an alert message to the mobile phone, while the LDR and IR sensor is also used to detect the presence of light and the motion. Okay. Malaysia's present street lighting system has been found to be inefficient and need of constant repair. Okay, for your information, basically in Malaysia we use the timer which will be set at 7 p.m. or 7:30 p.m. and 7 a.m. or 7:30 a.m. in the morning. The various street lighting systems are controlled by a light sensor or time switch that turns on the light at night or low light intensity during the day and turn them off during the day. Therefore, by implementing and utilizing the technology of the IoT-based smart street lighting system with fault detection, energy consumed for the street lighting system can be reduced and the energy will not be wasted. Okay, this is the problem statement for this project. The first one is the faulty street light, which is the lightning network operator or the lightning technician does not know when the certain lamp needs to be repaired until the complaint is lodged. So when the complaint is not lodged, then no one will know the street light is in a damage or in a bad state. Okay, the second one is the maintenance cost. Maintenance cost is high to repair the broken part or huge damage. Okay, basically there is two types of maintenance which is the preventative and the corrective maintenance. So the preventative maintenance is when there is not bad damage happen to the certain materials such as street lights than the corrective maintenance. So when like we want to prevent the bad things from happen to the materials, so we will use the preventative maintenance. So the cost will not as high as the corrective maintenance because corrective maintenance is when there is any bad damage happen, then the maintenance will be done. Okay, the third one is the wasted energy. When the bulb not light up, the energy flowing through the street light will be wasted. Okay, the project objective is to design and develop a simple IoT-based smart street lighting system with fault detection. Second is to test the system functionality so that it can alert lightning technician on broken lamps. Third is to analyze time taken for the message to be delivered to the lightning technician on duty. Okay, this is the scope project. First is to the circuit design and develop. Basically, for the circuit design, I'm using the Pro Tools software and the program develop. I'm using the platform name Arduino IDE to connect the coding to the Arduino microcontroller. Okay, the second one we will test is the system functionality. The system functionality we will test it if it is function by looking at the message if when the fault is detected. When the fault is detected, the message should be sent to the mobile phone. That's when we will test the system functionality. And the third one is to analyze the prototype. When the message is sent to the mobile phone, we will take the time taken for the message to be received from that mobile phone. Okay, this is the literature review of the project. Every project use different types of materials, so every project have their own pro and cons. Okay, for the first one, okay, basically it can regulate switches because it use a lot of switches in the project, and but it does not explain how it works. So it is stated that when fault detection circuit is broken, the voltage will become zero. It is only the theoretical evidence and it not exhibit the simulation findings, not in the real world experiments. Okay, the second one is the project goals is to design and create smart street light system that use wireless sensing network technology to save energy and make maintenance easier. The LED light source ensure optimum energy efficiency in brightness, while adaptive control based on environmental data is used to significantly improve energy saving. Okay, for the third one is it using the Ethernet connectivity, but the system become inefficient as the number of incidents increase. Okay, Internet is also inappropriate for real-time application because of its non-deterministic properties. Okay, this is the fifth of the table content, which is methodology. Okay, this is the project flow from the problem identification to collecting information, identify appropriate software to design the circuit, program development, and simulation test. So when the simulation test show not quite a good result, so we will design the circuit again and develop the program again and again until it is succeed to test the functionality, which means that the message can be sent and we can analyze the result. Okay, this is the component used, which is Arduino Uno, LDR, breadboard, wires, LED, infrared sensor, resistor, and also the important is GSM SIM900A modem. It allows us to send a alert message when there is any fault detected. So this is the block diagram. I use the input, process, and output block diagram, which is the input is power supply, LDR, IR sensor, while the process is Arduino Uno. We will send the output to LED and GSM module. Okay, this is the flow chart of my project. It's stated when the sunlight is available or not, or is the object detected or not. When the light on with maximum intensity and with minimum intensity. This is the result, the initial result. This is the simulation. I'll start from. But this is without the fault detection yet. So when I start the simulation, the LED will turn on, but with dimmer intensity. But when I trigger the IR button, then it will glow with the high intensity. The same goes with the second and the third one. So when there is any move, so this is with low intensity. When there is no light, but if the light is present, it will stop. And when the light is present also, if the IR is triggered, it will not glow up. Okay. Okay. This is for the fault detection result simulation. Okay, this is for the second simulation. Is the fault detection. So it is stated that street 1, street 2 and street 3, the LDR represent the street. So it is in a good condition, but when there is any fault happen in a certain intensity, then it will show that the street 2 in a fault. So for example, if it happened to the street 3, the street 3 also in a fault. Okay. So the conclusion is this project can save a lot of time to do the maintenance because it can locate the exact faulty street light. Then when there is any damage or defect to the street light, this project may make the lightning technician operate more efficiently and energy will not be wasted. Okay. So the project planning is I will continue to work on the simulation and coding for the project to be succeed and can function accordingly. Here is the Gantt chart for PSM1. It consists of 13 activities for this SEM, and this is the weeks estimated to do the plan and actual do. Okay. This is the Gantt chart for the PSM2. This is only the planning for the next SEM. Consists of 9 activities. Okay. That's all for today. Thank you for watching my presentation.